Hi friends, today we are discussing about dipole moment. So when you get the question about dipole moment, you may require to write about the application, how we can determine the dipole moment as well as the limitation. So what do you mean by a dipole moment? First of all, we would like to know what do you mean by a dipolar molecule? Dipolar molecule means a molecule in which we can see two regions. One is the positive side and next one is the negative side. And these two charges are well separated due to the uneven distribution of electrons in the molecule. So let the molecule be like this positive and negative charge as a whole neutral molecule is there. When the charge separate, what happen is that at a particular distance, the charge will separate as positive and negative. And due to uneven charge distribution, the molecule seem to be a dipolar molecule. So the best example for the dipolar molecules are water, hydrochloric acid, etc. So this is the general description or general representation of doing a dipole moment, and it is represented by mu. So in case of water, we can see the hydrogen is the as well as oxygen is the where oxygen is an electronegative atom. So what happens is that oxygen will show a greater tendency to withdraw the share pair of electron toward it. As a result, what happens? The hydrogen atom assumes a positive charge, and we can see a positive as well as negative centers in the molecule. So we are supposed to draw a schematic representation of dipole moment as well as give an example for dipole moment where mu and the unit is d pi. So as we said, the magnitude of charge separation we are expressing as dipole moment. So how we can define dipole moment? As dipole moment is defined as a vector, means it is having a direction equal in magnitude to the product of electric charge and distance. That means dipole moment is a product of electric charge and distance and having direction. So we are calling it as vector. So it is having a direction of the line joining the positive and negative centers. So this is the ammonia. So it is we are telling vector. So to the nitrogen we want to show the direction. So in case of ammonia, if we are finding out or determine dipole moment, we will get mu is equal to 1.46 divide. This is the water molecule dipole moment. So mathematically, dipole moment we can express as dipole moment mu is equal to distance into charge, where distance we can represent in terms of r and charge is e. So in Celsius unit, the unit of dipole moment is debye, and 1 debye is equal to coulometer. And this coulometer is equal to 3.366 into 10 raised to minus 30. So in this dipole moment, we can see the relative polarity of the molecule. And if it is like having more than one molecule, we want to sum up the bonds and we want to find out the dipole moment. Going to the applications of dipole moment, we can use the dipole moment concept in solubilization of a drug. So if a solute dissolved in a solvent, the permanent dipole of water having or showing an interaction with the solute. And this type of interaction will enhances the solubility. So we can use different type of solvent. Some solute are symmetric and planar. So in that case, what happens is that because of the solute or solvent, it will get polarized because of the polar or dipolar molecule, and thereby it will enhance the solubility. So in solubilization of drug, we can see the application of dipole moment. Second one, in crystalline nature of solid. For example, if a solid is dipolar, means it contains two poles, the dipole moment contribute to the orientation, how the molecule have to orient, and we can see the arrangement in the crystal lattice. For example, the ice crystals are organized because of this dipole moment. Third thing we can see in case of drug receptor interaction. And fourth application is that therapeutic activity of drug also we can see the influence of dipole moment. So in case of DDT, it's an insecticide, right? So in this DDT, we can see the more activity is shown by the para isomer, and it is having a dipole moment of 1.10 d. And in that case, what happened is that this DDT is less water soluble and it is more lipid soluble, and this will penetrate the insecticide and show maximum activity. Whereas in case of orthoisomer, it is less lipid soluble and least toxic. Apart from that, we can find out the chemical structure of the compound using this dipole moment. So as we know, dipole moment is the product of distance and charge. We will get the in Debye units, right? So normally the experimental value should be less than the theoretical value. Second thing is that by using dipole moment, we can identify the shape of the molecule. Normally, we are able to find out the linear structure of the molecule can be decided with the help of dipole moment. In case of carbon dioxide, we can see the unit as 0 debye and chlorine molecule. So in case of dipole moment, if the molecule is having linear shape, the dipole moment is 0, and the dipole moment also help us to find out or identify the shape and bond angle. If the bond angle of water is 105 degrees, right? So in that case, dipole moment help in deciding the shape of the molecule and bond angle. The dipole moment also help us to decide the arrangement of groups. In case of para-isomer, means the molecule or the substituent are in the opposite side. So in that case, the dipole moment is 0. So if the dipole moment is 0, we can tell that molecule is having symmetric shape. Apart from that, dipole moment help us to identify the geometrical isomer. In case of trans, we can see a symmetric pattern. So in that case, it is having less dipole moment. Next question is that how we can find out the dipole moment. So we are telling if we are keeping a solution of polar molecule between two oppositely charged plates, let it be negative charge and positive charge, and we are keeping the solution, this solution having a tendency to align along the direction of the fluid. So what happened is that it will align like this, means positive negative, it will align like this along the direction of the field, and it will show a change in the energy. So when we are switching off the electrical circuit, we can find out the electrical capacitance. So by noting out the electrical capacitance, we can find out. So this is all about the dipole moment. Hope this video will be useful for you. Thank you for watching.